In this topic, we're going to take a look at basic data shaping mechanisms in R. So we're going to start out by taking a look first at R data types. Eventually, we're going to take a look at the different types of R objects and data types that we can build date and time processing, which of course is a very important part of the kind of data shaping that we often have to do on data sets, text processing, and then some string operations. But let's get started first by taking a look at R data types to really get a fundamental understanding of how R handles different types of data. So after completing this lesson, you should be able to explain the difference between the mode and the class of an R data object and use R functions to find out what the class of an object is versus the mode of an object. We'll also show you how to convert between different data types and how to do conversion on the fly. We're going to show you how to assess the mode and class of an object and how to create one particular type of object called a vector, which is one of the most important fundamental data types of R along with the data frame. R stores everything internally as objects. It's actually an object-based language. And one of the most important set of objects are constants, text, the null object, the missing value object, the not a number object, and the infinity object. So if you look at this, a constant is basically some numeric value like 8, -3, 3.14, and so on. Text is some kind of a string of characters like CS6020. Then we have null, which indicates a null reference. So that basically is used when you have an object that's not really any object. It's an empty object. It's a null object. We often have the object NA, and we saw that before, to indicate a missing value. We use NaN as not a number, so that's an object that corresponds to something being not a number. And the INF object representing the infinity object. Objects themselves are stored in variables or identified through variables, or more precisely through identifiers. Now you assign an object to a variable using the assignment operator, which is the greater than dash operator right here. It's this operator right here. Now variables are fundamentally identifiers and are therefore subject to the following naming rules within R. Variable or an identifier must start with a letter followed by an upper or lowercase set of letters, digits, and the underscore. So for example, open date is all lowercase and it has an underbar in it. So that's a perfectly legal variable. It cannot contain special characters like pound, at, ampersand, percent, and so on. Range value again is a perfectly legal value, and so is I3. That's a combination of letters and characters. Actually, one other letter that you can put in here is the dot, the period. It actually allows the period, which is a little bit odd because a lot of other programming languages use the period as a way of getting to a property or a method of an object, whereas R doesn't do that. It uses actually the $sign for accessing a property of an object, but we'll see more about that later. Now when you build larger programs, most R programmers follow some kind of naming convention. In fact, most of them follow the camel case or the period separated naming conventions for variables and functions. Now for function naming, most R programmers use a lowercase as a starting letter, followed by mixed upper lower cases without underscores. In fact, most R programmers don't like using underscores. Again, it's a personal preference, but the camel case mechanism has really evolved as one of the most common naming conventions over the past 10 or 15 years or so. It's actually also used by Java programmers, PHP programmers, Python programmers, and so on. Regarding variable naming, we generally again start with a lowercase letter followed by mixed upper lowercase letters without underscores. Unless it's a constant. Constants a lot of programmers name by using all uppercase letters. But some programmers also use the period separation mechanism where they have lowercase letters separated with periods. So here's some examples of common identifiers. For functions, let's say start processing data set would be a good identifier. Starts with lowercase letter and then uses a mix of up and lowercase letters to separate the different parts of the name. Or load vals would be another example. Variable names and parameter names, start date, val, start dot date would be using the period separation mechanism, are all perfectly legal. This can be a little bit confusing right here when you have the period, because so many other programming languages use the period as a way of separating objects and the properties. So in another programming language, start.date would be the start object, and you're trying to get to the date property or attribute within this start object. In R, that's not the case. If you wanted to get to the property date within the start object, you would use start $date. So just be a little bit careful about that if you're used to other programming languages like Python, Java, or PHP. Now, objects in R have attributes. Specifically, there are two attributes that every object inherits, if you will, and those are mode and class. The mode is what kind of an object it is. It's kind of like the data type, if you will. It's either numeric, character, logical, and so on. And the class determines the type, the class of the object that it belongs to, which defines the operations you can perform on the object. Now, the mode of objects must match when you combine objects in an operation. So you cannot perform a mixed mode operation where different objects within an expression have different modes. The modes have to match, or if they don't match, you have to convert the various objects to the same data type. Now, some of the mode conversion happens automatically within R, so you have to kind of be careful what kinds of conversions R makes. They're often called coercions because one data type is coerced into another data type. It's actually very similar to what we have in other programming languages. Also happens in C, C++, and so on, where there is often data coercion. Although in both C and C++ we do have something called casting, which allows you to cast a data type from one type to another without actually converting the object. So just be a little bit careful when you're used to other programming languages that you understand how R treats the mode of an object versus its class. It's a little bit different than other modern programming languages like Java, PHP, and Python. To inspect the mode of an object and find out what mode an object is has taken on, you use the mode function. The mode function returns the mode of an object. So here's an example. Let's say we have the object num.obj. Again, please be careful. This is a naming convention. We're using the period separator, which is very common among our programmers, although I personally don't like that particular convention because I get confused with other programming languages that I know. And I always think that I have the num object followed by the property obj. But in any case, num.obj is assigned the sequence from 1 to 10 in increments of 2 using the sequence function. So now we want to find out what mode num.obj is. So we use mode num.obj and we get back numeric. Numeric because the different elements of that sequence, of that vector, are numeric objects. Here's a different example. So we have an object called logical.obj and we assign to it the vector true, true, false, true using the concatenate operator C. And if we now inspect the mode of that object, of course you get back logical, as you would expect. And here's a final example. Character.obj is assigned the sequence of characters H, E, L, L, and O individually, and we inspect the mode with mode.character.obj and we get back character. So that shows you the three different types of modes that an object can be, and you can't mix them. So you can only, for example, add two vectors or two variables if they're of the numeric type. You can only use objects in logical expressions like if statements if they're all of the logical mode, and you can only provide and perform string concatenation and string processing functions on objects which are of mode character. You wouldn't be able to add a numeric object to a character mode object. That would not work because you have mixed modes. Now, some important facts that you need to understand about mode to really understand how data gets stored internally within R. So R, first of all, stores numeric objects, having the mode numeric, as either 32-bit integers or double precision floating point numbers, depending on whether you use a period as a decimal separator or not. So if it's a decimal, then it uses double precision floating point numbers. If it's not using a decimal, then you get a 32-bit integer. If an R object contains both numeric and logical elements, then the mode of the object is numeric, and all logical elements are converted to numeric values, with true being 1 and false being 0. So this is an example of automatic conversion from one mode to another. And finally, if an R object contains character and numeric or logical elements, it's converted automatically to character mode. So if you perform, let's say, some string operation where you concatenate characters with an object that's of mode numeric, then the numeric mode is automatically converted to character mode. So there are some automatic conversions going on, like I alluded to earlier, but you got to know what exactly the conversions are so that you are not surprised when your ultimate final object is of a mode that doesn't match what you expect. So here are a couple of examples of automatic mode conversions. So here we have concatenation of 1, 3, true, 9, false. Well, of course, this is a combination of numeric and logical. True gets converted to 1, false gets converted to 0. So you see the ultimate vector has 1, 3, 1, 9, 0 because true is 1 and false is 0. Here's another example. We combine numeric, logical, and character. Everything gets converted to character mode, so the mode of the ultimate object becomes character. Now, alternatively, there are some functions that may make testing, particularly in if statements, a little bit better. So you can use that to make your functions, for example, more industrial strength by you checking to see if the input parameters you expect are of the correct mode. So you can use is numeric, is logical, and is character to test whether something is numeric, logical, or character. You basically just pass the object to it, and it returns you true or false. So for example, is logical of CNL would return you false because it's not logical, it's actually character. So is character of CNL would return you true. So you can put that inside an if statement. So that concludes the first part of looking at basic R data types. Later on, we're going to take a look at functions as objects and look at classes in a bit more detail.